All right, what's going on, everybody? Today's lesson 1.5. Today we're talking about histograms. In class, I'm not going to be there, but if you need to, please turn in your 1.4 activity. All right, go through the notes as we go through the video. Our learning targets today, we're going to make histograms of quantitative data. We're going to interpret histograms, and then we're going to compare distributions of histograms. Okay, so far we've talked about dot plots and stem plots to display quantitative data. Both of these graphs show very individual data values, right? For histograms, the benefit is for large data sets. This can make it difficult to see the overall pattern in the graph. We often get a cleaner picture of the distribution by grouping nearby values together. And when we do this, we make a new type of graph called a histogram. A histogram shows each interval as a bar, so it's like a bar chart, but it's different than a bar chart because the heights of the bars show the frequencies or relative frequencies of values in an interval, right? So multiple values within each bar, right? This bar represents all numbers between 0 and 5. This bar represents all numbers between 5 and 10, rather than an individual bar for 0, an individual bar for 1, 2, 3, etc. And this is a comparison, right? The figure on the left shows a dot plot, and then the figure on the right is a histogram of the exact same data. Okay, again, what we showed, or what we said up above, the dot plot on the left is much more individualized, but the histogram on the right makes it much more easier to see like trends. When we make and interpret a histogram, this is how we do it. Okay, we choose equal width intervals that span the data. Usually the minimum is using 5. Okay, but depending on your data, you can be bigger than 5. All right, make a table that shows the frequency or relative frequency of the data values in each interval. We draw and label the axes, put the name of the quantitative variable under the horizontal axis. And for the vertical axis, it shows the frequency or relative frequency of each interval. Make sure we scale the axes, place equally spaced tick marks at the smallest value, right? Again, just make them sure that they're evenly spaced out. And then when we draw bars above the intervals, make the bars equal in width and leave no gaps between them. So technically, it's another difference between this and a bar graph. A bar graph has space in between each bar. A histogram, each bar is going to be touching each other. Okay, an interval with no data values will just not show up as a bar at all. My iPad is freezing, so there we go. Okay, our example, how does the percent of foreign-born residents in your state compare to the rest of the country? Okay, the table, I did not include the table in the slides. It is on your notes. The table presents the data for all 50 states in 2011. Make a frequency histogram to display the data. Okay, so again, if you remember from the instructions, it said to make a table first. Okay, so if you looked at the big giant table that's on your notes and you organized it, okay, taking all of the percentages that range from 0 to 5, there were 19 states that had 0 to 5%. There were 15 states that had 5 to 10%. Hey, there were 9 states that had 10 to 15%, 4 states 15 to 20, 2 states 20 to 25, and only 1 state with 25 to 30. Okay, now notice the less than signs. Okay, so once we have a number, right, that number cannot be part of both. So notice it says 0 to all things less than 5. Okay, so that means anything that goes up to 4.99999, whatever will be in that first bar. But once we actually hit 5.0, that's the start of the next bar. Okay, so just be careful of that. We don't want any overlap in those values. Okay, and also if you were to calculate this as a relative frequency, we would divide it. 19 divided by 50 gives us a 38%. 15 is a 30%. This gives us 18%. 4%. Sorry, 8%. 4%. And 2%. Okay, so we can see that as a difference between frequency and relative frequency. Okay, now we follow the steps. Choose the equal width intervals that span the data. Note that this choice results in more than the minimum of 5 intervals. Okay, also notice that we follow the convention of including the left endpoint of an interval and excluding the right endpoint when making histograms. Okay, we already made the table. We should now draw and label the axes, scale the axes, and draw bars. Okay, so again, we are creating our data. Notice it says number of states. In the first one from 0 to 5, it was 19, so we would find 19. We'd draw our bar. And again, it's right over here. This is your final answer, but we're gonna actually draw it in. From 5 to 10, it was 15 states. From 10 to 15, there were 9 states. Then there were 4. Then there was 2. And then there was 1. Okay, and again, like I said, over here to the right is what it should look like, but we wanted to practice drawing. And again, remember the benefit of the histogram is to notice trends, right? When we make a histogram like this, it's very, very obvious to see what our trend is. It's very obvious to see that this is extremely skewed to the right, all right? And if we were to do this as a dot plot, it would still show that it's skewed to right, but doing it this way as a histogram just makes it that much more obvious, okay? Remember, the trade-offs, right? Dot plots and stem plots are much more individualized. You can see more specific data, you can see more details, but the benefit of a histogram is you're gonna see the overall pattern much more clear. Okay, our next example here shows 2 different histograms. The one on the left uses the intervals of width of 5. The one on the right uses intervals half as wide, so meaning going from 2.5 intervals. The choice of intervals in a histogram can affect the appearance of the distribution. Histograms with more intervals show more detail, but may have a less clear overall pattern. And again, right, in the right-hand histogram, in this one here, you can still very much tell that it's skewed right, okay, but this one is just so much more obvious that it is skewed right? It makes it cleaner. So changing your interval can make a difference. Just keep that in mind. Okay, our next problem. Use the data table from the previous example and the histograms in the figure to answer the questions. Okay, what percent of states have less than 10% foreign-born residents? We already did that, less than 10. If we come back up here, sorry, excuse me, less than 10, that would be these two combined, right? So that answer A would be 68. Describe the shape of the 2 graphs. That's the one up above. Okay, again, we both know that they are both skewed right. But if we look again, the left-hand graph is much more clear. The left graph is more clear and obvious of the skewedness. Okay, and which state is the possible outlier in the right-hand graph? And again, here, when we have the right-hand graph with the smaller intervals, okay, we have something that is somewhat of an outlier because there's a gap. When we change the interval to, in the left-hand one, there is no outlier. They're all connected here, okay? And like I said, I didn't put the actual table in the slides, so if I look, that would be, I'm pretty sure that would be California. Yes, California was 27.1, and so that would be that answer there. That would be California. And again, if we were just looking at graph A, the left-hand graph, we wouldn't even call it much of an outlier. So your intervals can make a difference of what you are seeing. Okay, let's think about it. What are we actually doing when we make a histogram? The dot plot in part A shows the foreign-born residents' data. Okay, and again, the dot plot in A is much more individualized. Okay, we can see it each individual data point, but again, it's not super clear. We could still say that this is skewed left because most of the points are clustered to the left, and it drags out much thinner to the right. But once we start grouping it together, it makes the data clearer. Okay. So again, this is still a dot plot. This is a combo of a dot and a histogram put together. And then in the last one, we just make it as a regular histogram, okay? And again, it's way better to see the overall trend, okay? But then we also need to be careful. Are we biasing the data? In some ways we are, okay? When we have the dot plot here in A, it's more obvious that California is an outlier. When we make it a histogram, there's no outlier. Okay, so make sure how do I want to say this? Just remember that each type of graph has a different benefit and unfortunately a different downside as well. Okay, so a histogram, the benefit is that it's much easier to see trends. It's greater for larger sets of data, but it can bias the data in terms of outliers. The benefit of the dot plot is that it's much more individualized, it's much more specific, but it's harder to see the overall trend. Okay, histograms can also be used to compare the distribution of quantitative variable in two or more groups. It's a good idea to use relative frequency when comparing, especially if the groups have different sizes. Again, we've talked about this already in class. Be sure to use the same interval when making comparative histograms so the graphs can be drawn using a common horizontal axis. Okay, so our question is it true that students who graduate from high school earn more money than students who do not graduate from high school? To find out, we took random sample of 371 residents, 18 and older. The education level and total personal income of each person was recorded. Following are relative frequency histograms of the data for 57 non-graduates and 314 graduates. So again, right, the amount of people in each category is very different. So it wouldn't make any sense to use frequency. It makes much more sense to use relative frequency to compare between the two. And again, right, this is the top one, let's call it A, is the non-high school graduates, B is the high school graduates, and we can see there is clear differences. So for the shape of A, it is heavily skewed right. B is still skewed right, but much less. Okay, the center, again, we haven't learned the official way to calculate the center, right? If we looked at the literal center versus the peak, again, the center of A is much further to the left. The center for B is much further to the right. Okay, if I were to guess, the center, like the literal center of A is about right here, but because of the amount of data that's over to the left, I would say maybe the center would be about right here, whereas the literal center of B is about here, but again with the the skewedness, I would say the center would be maybe about right there. Again, we will learn later on how to mathematically actually find out what the center is. For the variability, remember variability means how spread out. Okay, I would say that graph A has low variability, very clustered on the left. That's a L. B is larger variation. It's more spread out. And then outliers, there are no outliers in A. Potentially outliers maybe around like it's that 130 to 140, but even then it's not really much of an outlier because there's not too much space in between, right? So again, comparing and contrasting the two histograms there. And then at the last page of your notes, I did not include it in these slides, but it's the same tiny URL that we have used in class already. So that same tiny URL, even though it says dot plot in the link, you can make dot plots, you can make stem plots, and you can make histograms. We will be making histograms tomorrow when we do our 1.5 activity. Okay, so here's just some pros and cons of the three graphs we learned. For dot plot, it's good for small data sets, easier to see gaps and outliers. It's time consuming to make, and it's hard to see frequency. For stem plot, it's also good for small data sets. It's a lot easier to make, but it's kind of harder to see the distribution because it is vertical for one point, and then it also kind of groups them and skews the data a little bit. And then for histogram, it's better for larger data sets. It's good to find the overall trend, but it's much harder to see details and harder to see gaps and outliers. Okay, there is the assignment. Remember, go into your textbook. Your homework questions are 1 through 17 odd. Okay, good work. Let me know if you have any questions. Go Mustangs.